All right, on to problem 1.2. So for this problem here, we're given three of these states. Part A, it says for each of these states, find another state that is orthogonal to each one of these. Part B we'll do in the next video. But first of all, so in order for two states to be orthogonal to each other, if we take the inner product between the two, we should get 0. That means they're orthogonal. Not geometrically orthogonal. In this case, it's going to be more conceptually orthogonal. Think like heads and tails. Those are orthogonal states because if it's heads, it is not any tails. It's not some mix of like half heads and half tails. If it's heads, it's not tails. If it's tails, it's not heads. So like if you remember like I hat and j hat, those are two like geometrically orthogonal states because we have this y-axis and we have the x-axis, and that's more geometrically orthogonal. So there's no overlap. So if we have our j hat, it doesn't overlap at all with our I hat. But these states are more of a conceptual orthogonality. So hopefully that's clear. So anyway, so we have this, but what is this phi going to be? That's what we need to find out. So we can start off by kind of making something up here. So let's call this some scalar a up, and then another scalar b down. We just need to find out what these scalars are. They could be complex, but we need to figure out what these are. So if we were to take the bra of this, we would get a star bra up plus b star, because we need to complex conjugate these, down. Okay, so then we have the bra. So now if we do our phi inner product, let's do with our first state here. And again, that should equal 0 if they are orthogonal. So first we have this bra here, which is going to be this here. So a star up plus b star down. And then we have our ket here, which is going to be our first state. So 1 over root 3 up plus I root 2 over root 3 down. Now these are normalized already. You can kind of tell by looking at them. If you were to square both terms and then add them together, it's 1. So if you square 1 over root 3, that's 1/3. And if square this, it's going to be 2/3. So 1/3 and 2/3 is 1. You do that for each one of these. For this one here, when you square it with the complex conjugate, the negative I, that would become e to the 0. So the e would just kind of drop out, and you'd have 1 over root 2, 1 over root 2. Square those, and you get 1. So these are normalized already, so that's good. So anyways, back here we have our plus and our plus. So we have, how do I want to write this? We'll do a star over root 3. And our plus and our minus cancel, our minus and our plus cancel. Our minus and our minus would be plus, let's bring our I out front. So let's do I, b star, root 2 over root 3. And again, we want this to equal 0 to be orthogonal. Okay, so from here, first of all, let's go ahead and multiply both sides by root 3, just to get rid of that. So a star plus I, b star, root 2 is equal to 0. All right, so let's go ahead and solve for one of these variables. It's pretty easy here to solve for a. So a star equals negative I b star root 2. Okay, so now that we have this relationship between a and b, we can kind of make any state we want. And any state with this relationship here is going to be orthogonal to this state here. So if we say, let's just say b is going to be equal to 1, just to make the math easy. So if b is equal to 1, then b star is also 1, because you take the complex conjugate of a non-imaginary number, it just stays the same. So then a would become negative I root 2. So then now we have an a and a b value. So then our state could be equal to a, so negative I root 2 up plus 1 down. So this could be a state that would be orthogonal to this. There's also many states that could be orthogonal to this. Any state with this relationship would work. But let's go ahead and find the normalized, because this is not normalized. So let's go ahead and find the normalized state. So to do that, we know that for it to be normalized, then a star plus b, a squared plus b squared has to equal 1 if they are normalized. So knowing that, we can see what these values would be if adding their squares together would be 1. So we have a already here, solved for a. So if we were to say that this is a, then we can replace this term here. So let's say negative I b star root 2 plus, and b stays the same, b, this also has to be squared, don't forget that, equals 1. Okay, so now we're down to just one variable. Now we can solve for b. So in order to square this, this would be, so it would be the magnitude, so the negative would drop off. It doesn't matter anyways, it would end up getting gotten rid of. I b squared root 2, and then complex conjugates of this. So we have an I here, it's going to become a negative I. We have a b star, it's going to become b, and root 2 stays the same. All right, so a negative I and an I is going to make 1. So because I squared is negative 1, and then negative 1 would just be 1, so that cancels out. B star b would just be b squared. So we have b squared, and then root 2 and root 2 make 2. I'll put the 2 up front. So this term here becomes 2b squared, plus we have another b squared here. And again, that equals 1. So total, we have 3 b squareds. 3 b squared equals 1, which means, I'll go up here, which means b squared is equal to 1/3. And of course, b is equal to 1 over root 3. Okay, so now that we have b is equal to 1 over root 3, then now we can find a, because now we can just come back here. And if we know that b is 1 over root 3, then a star is equal to negative I. And now this is b, and this is b star. So we need to complex conjugate this, which is still 1 over root 3. 1 over root 3, root 2. Okay, so this is a star, and again, we want to find a. So let's complex conjugate this, and a is going to be equal to I, and let's just put the root 2 on top in the numerator, so root 2 over root 3. Okay, so then that's our a. So our state would be, this is for what's orthonormal to this first state here, would be equal to our a, which is I root 2 over root 3, plus b, our b, which is 1 over root 3. I should probably put our basis vectors here. So up plus 1 over root 3 down. Okay, so this would be the orthonormal vector that's orthonormal to this state right here. It's pretty typical though to keep our first term real and positive. And we have this I here. So what we can do is we can just multiply the whole, both terms by a negative I. So I times negative I would be positive 1. And then multiply this term by negative I also. So then what we would get, so this is the solution you might find if you were to look up the solutions. So I'll write it in this form, is going to be root 2 over root 3 up minus, because remember we multiplied a negative I across, so there's going to be a minus I 1 over root 3 down. Okay, so then that's our first one. Okay, so our second one, so our setup stays the same initially. So now we'll just do the second state here. So it's going to be 1 over root 5 up minus 2 over root 5 down. All right, our plus and our plus, we get a star over root 5. Plus minus cancel, minus plus cancel, and then we have our minus, let's do 2b star over root 5. And again, it's going to be equal to 0 to make it orthogonal. Multiply our root 5 across both sides. And we do that because root 5 times 0 is still 0 and just makes it easier. So a star minus 2b star equals 0. And I'm going to go ahead and solve for b this time, just in case there are any imaginary numbers. I don't think there is in this one, because last one we had the imaginary number in a and then had to kind of like flip it around. So I'll just go ahead and solve for b to kind of not have that issue. So a star is equal to 2b star, and that means b star is equal to a star over 2. All right, again, we have this relationship, and we want to normalize this. So we know that a squared plus b squared is equal to 1. We know we have our b star right here. So we have our a squared plus, and then our b is going to be a star over 2. Actually, so this is b star. I kind of wrote this wrong. It doesn't really matter, but because this is b star and this should be b, we should complex conjugate this, which means this would just be a. But again, it doesn't matter because we're going to end up multiplying it with the complex conjugate, so it doesn't really matter either way. But just for consistency and accuracy. So anyways, so this term is going to be a over 2 times a star over 2. All right, and then that's going to be a squared over 4. Or we can say 1/4. And this term stays the same, a squared. And again, that's going to equal 1. So we have 4/4 plus 1/4 is going to be 5/4. So we have 5/4. A squared equals 1. So running out of room here, a squared is equal to 4/5. And then so our a is going to be equal to square root of numerator and denominator is going to be 2 over root 5. All right, so that's going to be our a. And now that we have a, we can solve for b because our b is going to be right here. And this is going to be a star, so complex conjugate that. It's still 2 over root 5. So our b star is equal to 2 over root 5 over 2, which is going to be equal to 2 over 2 root 5. 2's cancel out, so it's going to be equal to 1 over root 5. And that's going to be our b star, and then complex conjugate that to get our b. It's still 1 over root 5, which means that our second state here is going to be equal to our a, which is 2 over root 5 up plus 1 over root 5 minus. Okay. 2 down, 1 to go. All right, let's see if I can, maybe I'll just make it kind of curved down here because I'm running out of room. But we have 1 over root 2 up plus e to the I pi over 4, 1 over root 2 down. All right, so our front terms here would be a star over root 2. Our last terms here would be plus e to the I pi over 4, b star over root 2 equals 0. Again, get rid of these root 2's, so we have a star plus e to the I pi over 4, b star equals 0. Let's go ahead and solve for b star. So e to the I pi over 4, b star, that's what I was doing, equals negative a star. See, whenever I skip steps, I freeze. And then b star is equal to negative a star over e to the I pi over 4. Okay, so now we have our b star. So now we have our normalization plus b star equals 1. Our a squared, did I say star again? I meant squared, plus, so our b is going to be the complex conjugate of this. Again, it doesn't matter, but we'll do it anyways, which would be a over e to the negative I pi over 4 if we complex conjugate that. And that squared is going to be equal to 1. All right, so this term here, we do a over e to the negative I pi over 4 times a star e to the positive I pi over 4. Okay? And a star a is going to be, so first we have this term stays the same. A squared, all my markers are dying on me today. A squared plus, so we have a star a, which is a squared, over, and then see here we have e to the I pi over 4 minus I pi over 4. It's going to be e to the 0. So we're going to be left with just another a squared equals 1. And then so we have 2 of the a squared equals 1, which means a squared is equal to 1/2, and a is equal to 1 over root 2. All right, so that's our a. And so we know that b is also going to be around 1 over root 2, but it could have that phase with our e's. So oh, did I just erase my b? Undo. Where's the undo button? It's okay, I'll just rewrite it. So we're going to have b star is equal to negative a star over e to the I pi over 4. Okay, so now our a we have right here, actually this is a star, so complex conjugate that, it's still 1 over root 2. So then that's going to be 1 over root 2 over, this is all negative, e to the I pi over 4. Okay, so then we're going to have that be equal to 1 over e to the I pi over 4 root 2. And this is going to be our a star. So again, this is our a star. So in order to get our a, we complex conjugate this. So to complex conjugate this, then a would be equal to negative 1 over e to the negative I pi over 4 root 2. And because this is a negative exponent, we can bring that to the numerator. So then that would be equal to negative e to the I pi over 4 over root 2. All right, and yeah, that looks good. So then our third state would be, oh, this is our, where did I go wrong here? I said a star, this should have been b star. This should be b star, which means this is b. Sorry about that. Okay, so yeah, this is our b term, that's our a term. All right, so our a term is 1 over root 2 plus a minus e to the I pi over 4, 1 over root 2 down. I just pulled that 1 over root 2 by itself there. So these are our 3 orthonormal states that relate to these states here. And I'll do part B in the next video.